Seasonal differences in weather are an important result of Earth's movement. As the planet moves, we experience changes in the amount of energy we receive from the sun. Depending on the Earth's movement, in Indiana, we may have snow. But in Australia, it is warm. Oops, let me hide this so you can actually read it. There we go. In this unit, we are going to be studying a geographer's perspective of our Earth and the sun's energy. Geographers look at the energy from the sun to study how crops grow and how people react and adapt to light. In light, daytime, and darkness. To cold and warmth. All life on Earth requires solar or sun's energy to survive. The amount of solar energy an area received depends on the Earth's rotation, revolution, tilt, and latitude. We're going to be going over those in this lesson. Imagine that the Earth has a rod running through it from the north to the south poles. As the Earth spins on its axis, different parts of the planet face the sun. It takes about 24 hours, or what we call 1 day, to complete one rotation. It appears the sun is moving from east to west across the sky to us, but it is actually the Earth, or us, moving and rotating, not the sun, that makes it appear that way. Next, number 2, revolution. As Earth rotates on its axis, it also follows a path or orbit around the sun. Earth's orbit around the sun is not a perfect circle, though. Sometimes the orbit takes Earth closer to the sun, and other times the orbit takes it farther away. We call that our year. It takes approximately 365 and actually 1/4 of a day for the Earth to complete one revolution or trip around the sun. The extra quarter we factor into our calendars every 4 years in February, but we're not going to get into that lesson. The final factor geographers study when looking at climate in areas is tilt and latitude. At any given time of year, some locations on Earth are tilting away from the sun, and others are tilting toward it. Places tilting toward the sun receive more solar energy and experience warmer temperatures. Those tilting away, yep, you guessed it, experience cooler temperatures. Remember those lines that go left to right on the globe? Latitude. They start at 0, called the equator. Where you are at on those lines also factors into temperatures. Let's watch a video clip that explains latitude and longitude and its movements more in depth. Give me a minute to get switched over here. I also need to mute it on my side so that it doesn't have the echo. So hang on just a second.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the Sun. This movement is called its revolution. One full orbit all the way around the Sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the Sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the Sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the Sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the Sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the Sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the Sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the Sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the Sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the Sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe, and night where it's not. Now let's see what the Earth's revolution around the Sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the Sun, or the lamp with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the Sun? If this were the real Sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days. And that's another year gone by. So what does all this show us? It shows that what looks to us to be the motion of the Sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the Sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That Sun, always gotta be the center of attention.
All right, so had a little bit of lag time in there. Sorry, thanks for patience. So now it's your turn. I just want to flip right back over to one of our slides here. Remember, we're looking at the Earth's movement, rotation, revolution, tilt, and latitude. So that's our focus lesson today. And we just watched a video explaining those types of things. But now I want you to just have an opportunity to try it on your own. We're going to watch this next video clip, and it's on something called the midnight sun and the polar night. And your job is to determine how people's lives would be affected by these parts of the year. And then once you're complete with this particular video, we're going to jump over to the agenda and you can take your quiz. So let me flip back over to this video and watch what the midnight sun and the polar night is. And your job while you're watching this is to be a geographer and determine how these two aspects will impact the human environment.
The top of the Earth and the bottom of the Earth, an interesting event occurs involving the location of the Sun in the sky. For a span of time each year, near the poles, the Sun never sets, all day and all night. This event is called the midnight sun. Now, having day simply never end wouldn't be a problem for penguins, which don't have jobs and such, but the situation affects human-populated areas as well. Regions like Alaska, northern Canada, northern Scandinavia, Russia, and Iceland are sometimes affected, all in their own unique way. In Svalbard, an island chain owned by Norway, the sun can stay up from April till August, 4 months without night. Well, what'd you expect from the most northern populated area in all of Europe? Keep in mind only 2,000 people live there. This can occur on the opposite end of the spectrum as well, polar night, although it's less consistent with area, since sunlight can refract throughout the atmosphere. Now, this doesn't have to mean total darkness. Sometimes the sky is still lit to an extent, even if the sun is under the horizon. Several kinds of polar nights exist. If you're a fan of actually seeing where you're going, then polar twilight is your best option. The sun is just barely under the horizon, so light can still reach out. During this, while daylight never truly exists, it's not constantly completely dark outside. With civil polar light, there's just barely any light during the day, even at noon. Nautical polar night occurs when the sun is between 6 and 12 degrees below the horizon. The only light ever visible is during midday. Now, only a few settlements in the world experience this, and out of those, most are military or scientific settlements. If you want complete depression, then astronomical polar night is for you, where no light whatsoever exists day or night at both poles for almost 11 weeks. 11 weeks of pure darkness. So next time you complain about 2 inches of snow or raining day, just remember, at least you get to see the sun.
All right, back to our PowerPoint, Google Slides presentation here. So just as we look, let me find one of the slides here for the information that you need. So the Earth's movement, if we're looking at this, as you are preparing for your quiz, make sure that you understand what rotation, revolution, tilt, and latitude would mean to a geographer when they're studying the aspects of how they relate to our world. Good luck on your quiz.